To solve this limit, I'm going to first check to see if I can simply take the 0 and put it in place of all of the x's so it simplifies to a number. So that is, can I merely go 1 minus cosine of 6 times 0 all divided by 7, 0 squared. If this simplifies to a number that is defined, that is going to be the value of the limit. Well, this is 1 minus, 6 times 0, that's really just cosine of 0. And, I'm not liking this already. The denominator is 0, because 0 squared is 0, times 7 is 0. Cosine of 0 is 1. And 1 minus 1 is 0. And what do you know? This is an indeterminate form, 0 over 0. I put a check mark to say we can use L'Hopital's rule, but that's an undefined value. So unfortunately, this did not work for solving the limit. But it does mean we can use L'Hopital's rule, which says, in this case, I can take the derivative of the top and the bottom separately and then figure out the limit of that expression instead. So that is, this should be equal to the limit as x approaches 0 of, all right, I'll differentiate the top. The derivative of 1 is 0 minus, okay, now I need to take the derivative of cosine of 6x. That's a chain rule that I have to use. Well, first, I have this negative here already, but if I look at just cosine, the derivative of cosine is negative sine. So we get a negative times a negative. And I'll copy down the 6x. But by the chain rule, I have to multiply by the derivative of 6x, which is 6. Unsimplified, that is the derivative of just the numerator. If I look at just the denominator, so I bring down the 2 to the 7, which gives me 14. Copy down the x and subtract 1 from the exponent. The derivative of the bottom is 14x. So by L'Hopital's rule, if this limit exists, it'll be equal to the limit that we started with. So I'm just going to simplify this so it looks a little bit nicer. The limit as x approaches 0. In the numerator, I'm not going to write the 0. And a minus times a minus is a positive, so I don't need to include anything here at all. And I'm going to choose to write the 6 in front of the trig function. That is, this is 6 times sine of 6x. And the bottom is 14x. All right, let's plug in the number 0 for x and see what the value is. That's 6 times sine of 6 times 0 all over, I'm not liking this. That's 14 times 0. I see what's happening here. 6 times 0 is 0. Sine of 0 is 0. The entire numerator is 0. And the denominator is 0 as well. So this is undefined. This is no good. But the good news is that since we got 0 over 0 again, it means we can repeat this process. We can use L'Hopital's rule again, apply it one more time to this expression. You can use L'Hopital's rule as many times in a row as is necessary, provided that you're getting indeterminate forms of 0 over 0. So we're not done. It's just that this did not work. Instead, I'm going to use L'Hopital's rule a second time. So let's see what happens. This is the limit as x approaches 0. So it's kind of like we're starting at the beginning again. I now want to differentiate the top. I'll place that here. And I also want to differentiate the denominator, and I'll put that here. So the derivative of 6 times sine of 6x, I'll copy down the 6. The derivative of sine is cosine. It'll be cosine of 6x. But by the chain rule, since I have a 6x, I have to multiply by the derivative of that at the end. So you actually get another 6. In the denominator, the derivative of 14x is just going to be 14. And if I simplify this so it looks a little bit nicer, this is the limit as x goes to 0 of, 6 times 6 is 36. We have cosine of 6x all over 14. Okay, I'm going to try again. I'm going to try to plug in 0 for x. I get 36 cosine of 6 times 0 all over 14. And, oh, well, this is cosine of 0. And before we saw that cosine of just 0 is 1. So this whole thing's equal to 1. 1 times 36 is just 36. I forgot to put that 1 to say the denominator is 14. But that is 36 over 14. I think there's a common factor of 2 that I can remove from both the numerator and the denominator. Factoring out a 2 from the 14 gives me 7. Half of 36 is 18. So in terms of the final answer, as an improper fraction, it looks like that it is 18 over 7.